Okay, these notes are over representing quantitative variables with graphs. So in this example below, what we're going to do is we are going to create a histogram. So out of all these, we have the average income level for a household in all 50 states. It says to make a histogram, we need to put the data into bins. Bins are even intervals that capture our data. Okay, we're first going to do this by hand, and then I'll show you how to do it off to the side with Desmos. So first we have to identify the lowest and the highest incomes. So looking here, it looks like my lowest is Mississippi and my highest is Massachusetts. So I'm going to write my lowest of 65,648.61 and our highest as 127,460.73. And then I'm trying to create an interval around each of these incomes. So I need to pick a value lower than the 65,648. So for that, I'm just going to do 65 thousands, rounding to the nearest thousand. And then I also need to find something that is going to include that highest income. So I'm going to do something a little larger than 127,000 and make that 128,000. Okay, now we need to find our bin width. So in order to do that, what we need to do is we take our highest estimate minus our lowest estimate. So that's that 128,000 minus 65,000. And then we're going to divide this by 5. And the reason why we're dividing by 5 is because this is going to be our number of bins. And to make it simple, I would just always divide by 5. Just make 5 number of bins, especially when we are going to get into you creating a histogram on an FRQ. They're not going to give you a whole bunch of data to do that. They just want to see if you know how to create one. So 5 bins is perfect. And then we calculate this right here. And when we calculate it, we get 12,600. Okay. So that means between each of my 5 bins, so notice here I have 1, 2, 3, 4, 5. Each of my 5 bins, they have an interval of 12,600. And then what I'm going to do is I'm going to look at all of these states and I'm going to count how many fall within each interval. So you can go ahead and pause now and try it, and then come back and check to see if you got it right. So it was 3, 17, 15, 11, and 4. Okay. We're then going to use that data to create a histogram. Important concepts here is when we are drawing each bin, they must be a rectangle. The bins must touch, which is different than a bar graph where they are completely separate. And then we must label with the border value. And what that means, if we're going back up to our interval, we're going to start at 65,000 and then we're going to write 77,600 and then we're going to go to 90,200, so on and so forth. Okay. Here we need to make sure we are labeling everything correctly. So this is going to be our count. And if you remember up at that table, our highest count was 17. So I'm just going to go by 5s and go up to 20. Then on the bottom, this was our income in thousands. And here, I'm going to do a little squiggle to indicate a break in data, and I am going to be starting at 65, which indicates 65,000. So I have 77.6, 90.2, 102.8, 115.4, and then 128, and I'm just going to extend this a little further. Then I'm going to be creating my bins. So from 65 to 77.6 thousand, if you recall, that was 3. So I'm just going to go up and draw a little bar to 3, or sorry, a bin to 3. Then the next one was 17, so I'm going to go up to 17, color that in. The next one was 15, so I'm going to go up to 15, color that in. Then I'm going to go to 11, and then lastly 4. Okay, and notice that in this histogram, each of the bins are touching. Okay. In class, I showed you guys how to create a histogram using Desmos. I'm going to give a quick example using some of our data from Parkinson's. So in order to do this, off on the Desmos side, you're going to click on Functions, and then you're going to scroll down until you find Histogram. And then I'm just going to hit Enter to go on the next line. From here, since I'm using my Parkinson's data, I'm going to say P is equal to, and then I need to add a bracket, and then I'm going to start typing in my data. So remember in Parkinson's, we were seeing how many out of 12 you could guess correctly. So I'm just going to put in a bunch of random data. And see. Okay, let's go ahead and stop that there. So remember, I labeled this P for Parkinson's, so I'm going to put P up here for my histogram, and then I'm going to hit to the left. Okay, and then notice right here, I have more than 5 bins, so I can even change the bin width to make it a little wider. Let's say I made it 2, and notice when I made it 2, I now had 5 bins to easily see my data for my histogram. So that's how I would use it using some random data that we did with Parkinson's. Okay, next concept is a stem and leaf plot. And in class, I had you guys calculate your pulse rate and then tripled that and then found the average. And then as a class, we went ahead and collected a bunch of data and then use those data to create stem plots. Okay, so what I'm going to do is just again fill this in randomly because we did this in class. And I'm just going to do a couple here. Of course, if you were in class with us and you got the data, your data will not match this. Okay, so if you were absent, please make sure you are getting the data from your group so we can refer back to this data throughout the course. Okay. Now, the only thing we're going to look at here is we're just going to look at the pulse rates. So looking at my imaginary data here, I'm going to find the smallest value, which looks like 50, and then the largest value, or actually not 50, 46 right here, and then the largest value, which is 90, which means my stems are always going to be that very first digit. So I'm going to do 4, 5, 6, 7, 8, 9 from my 40s to my 90s. And then I'm going to look everywhere else at everyone else's average pulse rate, and I'm going to fill in the leaves, the second digits, and I'm going to make sure that they are in numerical order. So I have 46, and then I have 50 and 52, then I have 61, 61. Notice that since there was 2 of them, I had to write it twice. 63, 65, 66, 68, 69. Then I had 70, 76, 88, and 90. And then the most important thing here is to make sure you include a key. And that is so the user will be able to see what exactly this data is and how to read it. So when making a key, you can choose any portion of the stem and leaf plot. I'm just gonna choose the very first part, and I'm gonna say 4 bar 6 is equal to 46 BPMs, which was beats per minute since we were calculating the pulse. Okay. Now, looking at back-to-back stem plots, we can go ahead and pull in the male versus female data. Notice we're still using the same stems, okay, because it's still the same data. So I'm still going to do 4, 5, 6, 7, 8, 9. But now when I look back up at my data, I'm only going to look at the males first. So starting in the 40s, I had a 46. I had none in the 50s. But in the 60s, I had a 1, and a 9. In the 70s, 80s, and 90s, I had none for the males. For the females, my first one was in the 50s, and I had 50 and 52. Then I had 63, 65, 66, and 68. Then I had 70 and 76, and then 88 and 90. So in order to, again, have people be able to read this back-to-back stem plot is that you need to create a key for both sides. So this is going to be my key for the males. And we're going to look at this part right here. So 6 bar 4 is the same as saying 46 beats per minute. And then for the key for the females, let's just look at the one at the bottom here. And this is 9 bar 0 is equal to 90 beats per minute. Okay. And then lastly, we have a split stem leaf plot. And all this means is, let's say we have a bunch of data. Like I'm talking about, you go ahead and fill in the leaves, and this data is going on forever in one single line. It is either going to fall off the page or look disproportionate when we're looking at our plot. So what we do instead is we split the stem and leaf plot based on the ending digits. So for example, if I had the digits for the stem 5, 6, 7, but these were super long, instead I would write 2 of each stem. So 5, 5, 6, 6, 7, 7. And then the digits in the very first one is only going to be 0 to 4. And then the digits in the second one will be 5 to 9, and then continue down that pattern. We see this in this next example where it looks at the scores from last year's Unit 1 test. And here we're going to create a split stem and leaf plot based off of this data. So remember, the first thing we need to do is we need to look at all this data here and find the smallest test score, and that would be 62. And then we have to find the largest test score, which would be 96. Which means when I'm creating my stem, I need to be doing numbers 6 through 9, but making sure I am doubling each number. So 6, 6, 7, 7, 8, 8, 9, 9. Then I am looking through this entire chart, and I'm first going to focus on the 60s. So I have a 69 and a 62. The 2 will go on the first one because it's between 0 and 4. And then the 9 will go on the second one because it's between 5 and 9. Now we'll do the same pattern for all the 70s, 80s, and 90s. And if you want to pause and try it on your own, go ahead and do that now. And then I'm going to go ahead and give you the answer to check. So this would be 4, 5, 8, 9, 0, 0, 2, 4, 4. 8, 8, 8, 8, 8, 0, 0, 2, 2, 2, 3, 4, and then 6. And then most importantly is we create our key off to the side, and I'm just going to use that very first value here and say that 6 bar 2 stands for 62%. And notice how I'm putting that unit there. Very important when we are analyzing this data, because we want to tell the user what this is. Is this 62 dogs? Is this 62 people? No, this is 62% on the Unit 1 exam. Okay. Now what you're going to do is we're going to work on creating a dot plot. And you will actually do this the same way you did this either by hand on the Parkinson's lab or using Desmos. So again, just a formal definition, a dot plot is a type of graph that involves plotting the data values with dots corresponding on the number line. You need to make sure you label your axis and give it a title. You need to create a scale, and you need a dot for each data value. Okay. So if you look at this example below, it tells us to create a dot plot using all these values here. So what I'm going to do is I'm going to go to Desmos, and since this is all about quiz grades, I'm going to label my variable Q, and I'm going to say Q is equal to my bracket, and then I'm going to just type in all those numbers, so 36, 42, let's see how many 42s. 1, 2, 3, 4. Okay, and then I have 41. And then notice that the order does not matter. Okay, Desmos will put it in the correct order that it needs to be. Okay, so don't try to do that extra step and put it all in numerical order. There's no need. Okay, 43, 42, 43. Okay, so as I am finishing this up, I have all of my scores in there. I'm going to go ahead and go on the next line, and I'm going to go to functions, and same place I found the histogram, I'm now going to click on the dot plot. And since I'm using my variable Q to store my data, I'm just going to type in Q, and then I'm going to hit enter. And if you don't see it here, don't worry, you might just have to zoom out a little bit, and you'll notice here is all of my data. And then I'm just going to take that and then draw it down here. So here is my dot plot. And I'm going to make sure I have my scale starting at 35, going by fives, all the way to 50. This is the quiz score, so there's my title. And then my dot. So let's see, 1 there, 1, 2, 3, 1, 2. And then, of course, yours is going to look so much nicer than mine. But this is just an example here. Okay. So that's a dot plot, and that's how to create it using Desmos. Okay, our last concept here is cumulative relative frequency graphs. That is a big mouthful. Usually they just call these OGIVs right here. Okay, OGIVs. Or some people may call them other things, but mainly what this is, it's a graph of percentiles. And then remember, a percentile tells you what percent the data falls below that value. So when you think of percentiles, the easiest thing for me is to think of like your growth chart, like when your parents take you to the doctors and they, every time you go for your checkup, they do your height and your weight, and then they compare you to other kids, your gender and age, and see where you fall on the height chart. So for example, if I use an example of my daughter at 1 year old was in the first percentile, and what that means is that 99% of babies her age and her gender were larger than she was at 1 year old. Okay, so that's what that represents. For this one, we're going to be using the example of the 46 U.S. presidents when they took office, and more specifically their ages. And here they already gave us all the data for each of these intervals, and they want us to find the relative frequencies. Well, remember, relative frequency is just the frequency divided by the total. And our total here is 46 presidents, so we would do 2 divided by 46, 7 divided by 46, so on and so forth, to get the following percentages. So 4, 15, 28, 26, 15, 7, 2, and 2. And then for commutative relative frequency, what we're doing is we're adding them together. So just write the word adding. And what I mean by adding is we are going to look, sorry, excuse the bell. We are going to look at whatever was before the column. So for example, if we started this first column, since there was nothing before, that's the same as adding 0 plus 4, which is 4. Now on this next column, we look at this value, 15, and we add the value before it. So 15 plus 4 is 19. And we do that same process all the way down until we get to the very end. And what you should notice is that the value at the very end is very close to 100. The reason why ours is not exactly 100 is because we had to round in order to find our answer. So here, just make a note that this should be 100%. In our case, we had a rounding error because we rounded each of these percentage values, and we end up losing some numbers in the process. Okay, but just know that this should add up to 100%. Now I'm going to take these values and I am going to put them on my table here. So I have 4, 19, 47, 73, 88, 95, 97, and 99. And again, I want to make a note that this right here are percentiles. So that means the age group from 40 to 45 is in the 4th percentile, which means 96% of presidents were older than 45 when they became or started their presidency. Okay. So what we're going to create is an ogive graph. And in order to do that, very important is to make sure we label everything. So I'm going to label this as cumulative relative frequency. And since my frequency is supposed to get up to 100%, I'm going to go by 20s and label all the way up. So this is 20, 40, 60, 80, 100. And then here on the bottom, I'm going to be putting all of the age ranges starting from 40 going up to 80 and going by 5s. You too, bye. Okay, so continuing on our ogive graph, on the side, I put my commutative relative frequency, and I labeled that from 20% all the way to 100%, and then on the bottom, I am putting all of my boundaries here, and I'm gonna make sure I am plotting them at the end of the boundary. So I'm gonna be starting right here with 40, and notice how I'm doing a break here to show, okay, I'm not losing data. The data just starts from here. Then I'm gonna go up by 5, so 45, 50, 55, 60. I probably should have not made them so far away. Okay, let me redo that. Okay, so 55, 60, 65, 70, 75, 80. And then I'm going to start plotting my points. So at 45, there was about 4. And I noticed I just skipped one. Okay, so at 45 there was about 4. At 50 there was 19. At 55 there was 47. At 60, 73. At 65, 88. At 70, 95. At 75, 97. And at 80, 99, and then I would connect all of these points, ignoring my mistake right there, just by connecting the dots. And then I have my ogive graph. Give me 1 second, I'm just recording a video. And then from here, you have the graph, and notice how I didn't just connect the lines all the way through, I connected the dots. And then answering the 2 questions on the bottom, go ahead and look at those, try them on your own, and pause the video at this time, and then I'll give you the answers. Okay, so looking at number 1, it says, at approximately what age is the 30th percentile? So what I'm going to do is I'm going to look at my graph over here, and I am going to find the 30th percentile, which is about here, and I'm going to see where that connects on my graph. And you'll notice on my graph, it is in between 50 and 55. So I'm going to say about 52 in age. Okay, so zooming that in here, so I would say 52 is about the 30th percentile. Okay, and it says, what does this mean in context of the problem? So if 52 is the 30th percentile, then that tells us that about 70% of U.S. presidents was older than 52. Think back to the growth charts that I gave the example earlier. And then lastly, it says that Nixon was 56 years old when he was inaugurated. Approximate the percentile and then explain it in context. So let's see, 56. So we would go up to our graph over here, and I would say, okay, 56 is a little after this. And I would go look and say, okay, well, 56 based on my graph, and of course my graph is not perfect, it's a sketch. If it looks a little different on yours, that's okay, but just following what I have here, and maybe I could even go a little further, but it's still going to be close right there. I would say that about at the age of 56 years old, that that was about the, let's say, 56th percentile. Okay, so we would say that 56 age was approximately, and let's not confuse it, I guess, with 56, and let's just put the 58th percentile, because it's somewhere around there. We're just not able to concretely give an exact answer based off just a sketch. And then it says in context, what does that mean? So that means that Nixon at the age of 56 was, he was younger than 58% of presidents. So Nixon was younger than 58% of U.S. presidents. Or we could think of it the other way and say that 42%, we could say about 42% of presidents were older than he was at 56.